This week we begin our study of logistic regression. Previously we'd been studying linear regression, both single predictor and multiple predictor models. And what distinguishes linear regression from logistic regression is the response variable. We had previously had a continuous response. But in the event that we have only two values for our response, like does something fail or not? Is somebody going to get a particular diagnosis of a disease or not? Then we can't fit a linear model to it. In fact, we see in this slide here, we've got data dealing with damage to O-rings on the space shuttle, and there were only two possibilities, they had damage or not, and it would not be appropriate to try to fit a line through this data. We might possibly be able to fit an S-curve to it, and a logistic curve is an example of an S-curve, which I show on the following slide. Now in this demonstration, I'll be talking through example 1 from the notes, and specifically it's home equity data. And the two values for the response are, again, a 0 and a 1, and the meaning is whether or not someone defaulted on the loan, where 1 indicates default, whereas a 0 would indicate that the person actually paid back the loan. And on that slide introducing the example, I have the names and descriptions of the variables in the data set. Now let me go over to SAS and remind you that although I'll be focusing on the new content, like how to code a logistic regression model and what to look for in the results, you're not to forget the beginning steps. You still want to explore your data, see if anything needs cleaning, see if there are any outliers, and if they are, investigate them. Look at your scatter plots, that kind of thing. And I will be showing you some scatter plot matrices in just a moment. In fact, you can see that I have some warnings from when I ran this code. That was from the scatter plots because I've got so many observations. Not everything can be shown clearly on those plots. After we discuss the scatter plots, then we'll go directly to the model and the results. And it will take a while if you're running this yourself for SAS to actually process everything. That's why I've already run this and I've got my results waiting. Just because I can click over and show you right away doesn't mean that I get instantaneous results. Be prepared to sit for a little while SAS crunches your numbers. All right, so let's go ahead and take a look at my results, and I'll scroll back up to the top here. In my proc contents procedures, oops, let me not scroll so fast. In proc contents, I see that I've got most of these as numeric. There are a couple that are character. And we can look in proc freq to see a little bit more information about those character variables to see if we might want to convert. All right, here are my proc freq results. I've got my response variable called bad, and we see that about 20% of the borrowers in this data set defaulted on the loan. Then we've got the number of credit lines, and we see some people had quite a large number of credit lines. Then we see reason for the credit line, and there are only 2 values. This could be something that you convert to numeric, assign a 1 or a 0, see if that sheds any light on probability of defaulting on the loan. It may or may not. I didn't do that here, so let me just keep on going. This next variable here, year on the current job, And I see my values are a little bit different from what I expected. When I simply looked at the written description of that variable, I expected it to be 1, 2, 3, 4 years, but I've got decimal values in there. So this becomes more of a continuous rather than discrete. Delinquent, that's the number of delinquent credit lines. Derogatory, that's the number of major derogatory reports. The number of inquiries into credit history. And here we have our scatter plot matrices, and I'm going to try to show you more of these together at a time. Now for the first grouping, in fact I'll click back over and show you, I was looking at the response variable, the credit line age, the number of credit lines, the number of delinquent credit lines, the number of inquiries. So these all seem to deal with the number and age of credit lines, and then my other group seem to relate more to the value of the loan. There's a debt-income ratio. There's the amount requested for the loan. There's the amount that's still remaining on the mortgage. And there's the value of the value of the property? Let me double check. Value of the current property. And that second scatter plot group, scatter plot matrix, revealed something that I thought was interesting. I didn't see anything in the first group that just jumped out at me. But here, for debt income versus the response, notice after a certain point, all of those loans were in default. So that tells me there's some kind of threshold where if that ratio is a certain value or higher, I can pretty much guarantee that the borrower will default on the loan. I also see something else that's striking, where the amount that's remaining on the mortgage and the value of the property appears to have a linear relationship. Now remember, we don't want the predictors to be highly correlated with each other. That's true both in linear regression and in logistic regression. So I want to keep an eye out. I do not want both of those variables to remain in my final model. I'm going to put them both in the initial list and see if SAS kicks one or both out. If both remained, then I would need to do a little more investigating. And what I think I would do there, if that was the case, is look at each one individually against the response in a logistic regression and see if one is a stronger predictor than the other. All right, now I'll go back over to my code and show you how we type into SAS our model. And here it is. We have a model statement. We have our response first. But what makes this different from linear regression is that we must put the desired outcome in parentheses and the actual value in quotation marks. So we want to know the probability that someone defaults on the loan, and that's a 1 in the data set. A 0 means they actually made payment. And even though 1s and 0s are numbers, we're putting this in quotes, and that's important. And then on the other side of the equal sign, we put our list of predictors, and I'm specifying a selection method here, specifically the stepwise selection. And it's not necessary to list these out one per line. I just kept it that way so that you could clearly see the list of predictors. I find it easier to read that way than I'll list it out horizontally. But we are not going to be individually eliminating variables. We're going to let SAS do that using this selection method. So also one more thing to note, I've specified this plots equals all option to show the ROC curve and some other plots. And in order for that to work, I'm going to start with ODS graphics on. Now, like I said, I already ran this code. If I were to rerun it, we'd be sitting here a long time for the results. I'm just going to click over and scroll through these results, and we will see step 0, And then step 2, scrolling down. Step 3, scrolling down. Step 4. It's going to keep looking at various combinations until we converge on a model. And now after 7 steps, we have converged on a model, and we've got our summary table here. And below that, we have an analysis of maximum likelihood estimates table. That's important. That's what we will be using to write our equation. We've got our odds ratio point estimates. That's going to be helpful with interpretation. And then we've got some curves and some more stats. Now let's go back over to the PowerPoint for a moment. We want to know how good our model is. Let's take a look at summary of model requirements. We want our, hold on just a moment, our model fit statistics for intercept and covariance to be less than intercept only. We want to look at the testing global null hypothesis information, p has to be less than 0.05. Same with analysis of maximum likelihood estimates for each parameter. We're also going to look at percent concordant and c-statistic, and we want those to be greater than 70%. So let's take a look at all that in our results. And I'm going to scroll back up above my final step here. Testing global null hypothesis, less than 0.05. My intercept and covariance are less than intercept only. And then I'll scroll back down and find my c-statistic and percent concordant. Here's my percent concordant, 79.2%. And my c-statistic is 0.792. These numbers aren't always going to match. In this case, it looks like I can move my decimal over and have the exact same value as percent concordant. But the point here is that they both meet the threshold. And let's take a look at the ROC curve. Here it is. We want that to be as close to hugging these left and top axes as possible. If it's hugging the diagonal line, we do not have a good model. And we can see how with the various steps that SAS was taking by introducing new variables or removing them, how the c-statistic improved. That's the area under the curve. And then we have some more graphics here. I'm not going to take the time to look at those, but they might be interesting to you. Now let's go back over to our PowerPoint and talk about how to write the equation. And I'll show you how this table right here is the same as what we had in our results. Let me scroll back up. The analysis of maximum likelihood estimates. That's what we've got here. And we'll take those values and write our equation. And of course, we need to say what each of the variables is. So X1 was the age of the oldest credit line, X2 is the number of credit lines, X3 is the debt to income ratio, etc. Now, notice I did not write Y equals. I wrote L equals for the logit. And next week, I'll tell you how to take this equation and use it to make a prediction and how we interpret what we have. But that's for next week.